Hello, good day to you. Today, my topic will be about time measurement. This is part of a series of videos on the performance analysis of a Linux operating system. So that is, if you're working on a server and you want to do some performance analysis, you want to understand why some things behave the way they are, or how long it takes a particular command to run, or you wrote a particular program, maybe you wrote a Python script or Java application, wherever, and you want to know, you want to do a time analysis. Basically, things like you want to know how long the program spends in the kernel space. You want to know how long it spends in the user space, and how long it just takes to run. So basically, the time program is this is what the time program is for. So if I go to my terminal and if I run time, so basically you see it gave me three basic output. One of them is real, second is user, third is system. So the meaning of those are, the first one is real, so that is how long a particular program takes to run, basically the time from invocation to termination, that is from beginning to the end of that program. The second one is the user time, how long the application spends in the user space. And the third is system time, how long does it spend in the kernel space. So for example, let's say I run ls-l on the slash proc or slash proc. So basically I get my output, but let's say I want to know, how long, or I want to really know, how long this application takes to run. So I will time it. So I'll put time, then the command that I want to run and the parameters. So if I run this, you see it gave me my output at the end. So it told me from the beginning to the end. So that is from invocation to termination, or spend 0.0004 milliseconds. So uh, there's nothing recorded for user space, nothing recorded for system space in this case. So but before I proceed, I have to tell you that if you are on a bash, shell, if you're using the bash shell, there are two variants, of time that you will come across. You have to be aware of that. There's the built-in command and there's another one stored in the user bin time. So the built-in, the command, gives you basic information, like you saw, basically the real time, the user time, the system time. But the user being time, that was the external one that was created, gives you a little bit more information. It gives you, actually gives you a lot of information about, what takes place when you run your command. So let's do something, more, maybe that will give us something to work with, more data. So let's say I want to time, or there's a command called dd. Dd is I think it used to be called disk destroyer, but you can use it to copy, or a bit, bit for bit, like a byte copy bytes of files, from one place to another. So let's say I want to copy bytes of zeros. So I'm going to copy from dev0 uh, to dev0. Then my output, I want it to go to, let's say I want to create a file called demo1, and I want the block size to be 1 megabyte, and the count, I want it to be 500. So this, what basically does, is going to create a file called demo1 of size 500 megabytes. So block size is 1 megabyte and count of 500. So I want to time this operation. I want to know basically how long it takes. So it is done. So let's analyze it. So the real time is 0.611, the user time. There's actually no recording of the user time, so that means this operation did not spend any time in the user space. The system is 0.436, so that is basically the basic information this gives us. But like I said, there's a variant in the user being time that gives us more information. So let's create another file, demo2. This time around we're going to use the one, the user being time. And if we run this, basically, it's also going to give us some information here, but this is not the best way to use this. I think the best way is to use it with, let me create another file, is to use it with the -v option. So -v option gives us a lot of information. So I think this is actually like the best way to use this. So let's see. So you see, it gives us a lot of information. So one of the information is basically tells us the command we are running. It told us 0.00 in the user space, but the system time, that is the time spent in the kernel space, is 0.39. The percentage of CPU that was used was 78%. The elapsed time, this is like the real time, so is 0.50. Then some other very important information also are things like things that are related to the memory, or basically what is the memory that was consumed to run this application, and things like page faults. So the major page fault, minor page fault, and also context switches. So these are very important parameters if you are doing performance analysis, especially things like context switches. Context switches basically is, when the CPU, moves from one thread to another, basically, or in this case, move from the user space to the kernel space. So these are parameters that have that have great effect on the performance of the application. So things you see, things like file system outputs, that is how many bytes was written out, or page size. So this is a very, very good way to get a lot of information about what happens. So let's try it with another command. So there's another command, for creating files. It's called fallocate. So let's say we want to create a file of length 500 megabyte. We call it demo. Uh, let's call it demo 6. So you're going to use user being time, and giving it a -v flag. So let's see. So look at this command. This command actually, this command basically did not use the CPU. So I think that is interesting. So is 0 time in the user space, is 0 time in the kernel space, percentage CPU is 0%, elapsed time is 0.06, or number of context switches is 4. So if you are doing performance analysis and you look at something like this, you see that this program, I think, is relatively very performant, because the number of context switches is relatively lower. It basically did not even use the CPU. The So I think this particular application has been optimized a lot, as you from what you can see that it gave us. So because if I run ls or ls-lh on demo 6, you see this file is 500 megabytes, but it was created in a very efficient way. So this is how you analyze, your applications. Maybe you wrote an application, maybe a Python application, Java, or whatever application. You want to analyze it. You want to know, the context switches or page faults, or like in this case, there was one page fault. So things like context switches, page faults are expensive. If you have high numbers of context switches and page faults, then you have to be a little bit worried. And also the time spent in the kernel, time spent in the user space. So a very these are like very good way of analyzing your application. Maybe let's do one more. Let's say we want to let's do a ping. We want to ping yahoo.com or count. We want to do 5 pings to yahoo.com. Let's see. So after the ping, it gave us the analysis of what happens. So in this case, you see also again 0% of CPU usage, but the elapsed time in the real time is for the 15. So let's even compare. Look at the time reported by ping and look at the time reported here. They are almost maybe almost the same. So and also look at things like page faults, context switches. So these are very important, outputs. So for example, if you want to analyze your program further, like you may want to know why is there like 18, context switches, what's going on. So these are like very important parameters, for analyzing your system or your system. So let's do one fun thing. Let's try to run a program. Let's say I call a program called Pong. Let's see how long it's going to take the system to know that there's no command called Pong. So yeah. So basically uh one context switch, it was not even able to return any uh, CPU, nothing returned for user. So basically, it quickly determined that there's no program called Pong. So yeah, so these are like very interesting parameters and very interesting way to analyze your system. And also, if you want to get more information, you can run man on time. Or there's also one very interesting parameter is dash f. You use dash f with the user being time. You can generate formats. You can format, your output. Or so you can. There are some other parameters you may want to be familiar with, especially the format. But I think the dash v or dash v of verbose, in my opinion, gives a lot of um, information. So I prefer running it that way. So, or for example, if you want to use it with formats, get some formats. You can let me copy this and run. So I'm running dash f, then using some formats, and the command is ls. So let's do that. So you see what. Oh, sorry. So yeah, that's one thing. So this dash f did not work with time. It is going to work with user being time. So that is one caveat, something you have to be aware of. So you see, so now this is the output here. So basically, that is what I'm doing in this video. Talking about time or measuring time and analyzing, what goes on when you run your application. And I think this is one of the most basic tool, for system analysis, performance analysis. So thank you for watching. See you in some other videos. Bye.